The question is like this. In the reaction of oxalate with permanganate in acidic medium, the number of electrons involved in producing one molecule of CO2. Potassium permanganate MnO4- will act as a strong oxidizing agent and oxidizes oxalate ions to carbon dioxide. Let us take the half reaction. Oxalate ions getting oxidized to CO2. Let us balance the reaction. There are 2 carbon atoms here. I'll put 2 here. And now, when we balance the charges here, it is -2 here. So, I will add 2 electrons this side to balance the charges. From this reaction, we understand that one molecule of oxalate ion will lose 2 electrons in order to get oxidized to carbon dioxide. Here the question says the number of electrons involved in producing one molecule of CO2. Here, when 2 molecules of CO2 are formed, 2 electrons are lost by oxalate ion. Oxalate ion is getting oxidized here. It is getting oxidized. During oxidation, it is losing electrons. So, one molecule of oxalate ion will lose 2 electrons to produce 2 molecules of CO2. Here the question is, to produce one molecule of CO2, how many electrons it has to lose? It should be 1 electron. So, our answer should be A option here. The question is the total number of Mn double bond O bonds. The total number of MnO double bonds. Actually, Mn2O7 is a molecular structure. Composed of 2 MnO4 tetrahedras linked by Mn-OMn bond. Oxygen bridges 2 manganese atom. It looks like this. Actually, MnO3, another MnO3, they link with an oxygen atom here. Like this Mn with 3 oxygen atom in the tetrahedral manner and 1 oxygen this side, another manganese with 3 oxygen atom and with oxygen makes a tetrahedral structure. Here manganese oxygen, we all know that manganese valence electrons are 7 in number and they will form 7 covalent bonds. So here manganese will show 1, 2, 3, 4, 5, 6, 7 bonds, and here also 1, 2, 3, 4, 5, 6, 7 bonds here. Here our question is the number of MnO bonds here. So the number of MnO bonds are 3 here and 3 here, totally 6 MnO bonds are there, and there is one there are 2 MnO bonds here, MnO bond and MnO bond. There are 2 MnO single bond, 6 MnO double bonds in the structure. Our question is to find out MnO double bond. There are 6 in number, so the option should be C option. The question is, which of the following reactions are disproportionation reaction? What does disproportionation reaction? Where the reactant will get oxidized also reduced also in the reaction. We have to figure out which central atom is getting oxidized as well as reduced and undergoing disproportionation reaction in the following examples. The first option is Cu plus getting into Cu2 plus Cu. We can clearly see that here it is plus 1, this is plus 2 and 0. Here cuprous ion is getting oxidized to cupric and getting reduced to copper. So this should be the disproportionation reaction. Let us check out the remaining also. Where here second option MnO4 2 minus 2 MnO4 minus and MnO2. Here it is in 8 minus 2 it is 6, whereas here it is 7, whereas here it is 4. 8 minus 1 7 and 8 minus 2 6 and it is plus 7 and here it is plus 4. It is also getting oxidized, this is getting reduced, meaning this also should be the option, B also should be the option here, meaning it can be the disproportionation reaction, not the option, disproportionation reaction. A and B should be the disproportionation, so A option should be possibly correct answer. Let us check out with the C option also what it is. KMnO4 changing into K2MnO4 plus MnO2. Here oxygen is, manganese is in plus 7 oxidation state, whereas here it is plus 6 and it is plus 4. Both are undergoing reduction only. This is also reduction, this is also reduction. It is not disproportionation. Let us check out next option where you see MnO4 minus and Mn2 plus converting into MnO2. Look at this. There are two reactants here which are in plus 7 and plus 2. Here it is plus 4. This is not disproportionation, rather it is comproportionation reaction where two reactants will convert into a product whose oxidation state lies in between. So this is not disproportionation where one reactant will get oxidized and reduced products, whereas there are two reactants here, we are getting only one product which is in the intermediate oxidation state, which is called as comproportionation reaction, which is also a type of redox reaction. So this also cannot be the option. So our final answer should be A option, which is A and B both are disproportionation reactions. The question is this way: which of the following compounds show color due to DD transition? Compounds are colored due to two reasons. Compounds are colored are due to two reasons: due to DD transition and due to charge transfer. Here DD transition are due to unpaired electrons present on the central atom in the compound. Here the question is due to DD transition. So we have to figure out the atom in the compound whether it has unpaired electron or not. Let us take the first option, CuSO4 5H2 wave 5H2O where copper exists in plus 2 oxidation state. Copper valence electrons are 11 in number. Lost 2 electrons will have D9 configuration where there will be one unpaired electron in its d orbital this way: 1, 2, 3, 4, 5, 6, 7, 8 and 9. There is one unpaired electron here. So copper sulfate is colored due to DD transition, meaning it will be blue in color. Hydrated copper sulfate is blue in color due to unpaired electron in its d orbital and shows dd transition. Therefore, our answer should be A option. Let us check out with the rest of the option. Potassium dichromate. Dichromate here exists in +6 oxidation state where chromate has 6 valence electrons and lost all the 6 with no electron d0 configuration, but still this is orange in color due to charge transfer. Not by dd transition, so this is not the answer. Second one, potassium chromate, which will be yellow in color. Here chromium exists in +6 oxidation state, lost all the electrons, no electrons d0 configuration, but still yellow in color because of charge transfer. This is also not the answer. KMnO4, potassium permanganate, is purple in color. Here manganese is in +7 oxidation state. Valence electrons are 7. Lost all the 7 electrons with d0 configuration. No unpaired electron but still colored due to charge transfer. So our option is A option is right here. The rest all are the wrong options. The question is like this. Potassium dichromate acts as a strong oxidizing agent in acidic solution. During this process, the oxidation state changes from is the question. Let's write the equation. Potassium dichromate K2Cr2O7 in acidic medium H2SO4. What happens? Potassium dichromate will act as an oxidizing agent and it will undergo reduction. Reduction into what? Reduction into chromium ion Cr3+. Here we will find out the oxidation state of chromium. It is K2Cr2O7 where potassium is +2 here and this is -14. So it is -12 and there are 2 chromium atoms by 2 is equal to -6. Take it out, then chromium exists in +6 oxidation state. So our answer is from +6 to +3 it is undergoing reduction. So our answer should be +6 to +3, that is B option. The question is like that. A pair of metal ions that can give a spin-only magnetic moment of 3.9 Bohr magneton for the complex this one. Meaning they are telling this is the complex MH2O taken 6 times Cl2. In this complex, the pair of metal ions that can give spin magnetic moment of 3.9, meaning which metal will give magnetic moment of 3.9 Bohr magneton is the question. We have to figure out the metal here. The metal whose magnetic moment is 3.9, meaning it is assumed that it will have 3 unpaired electrons. How did we come to conclusion? Look at this. Root 4 is equal to 2. Root 9 is equal to 3. Root 16 is equal to 4. Suppose we assume that this metal is having 3 unpaired electrons, then according to the spin magnetic formula, root n into n plus 2. N is the unpaired electron. If you assume it is 3 electron, then it is 3 into 3 plus 2 is equal to root 15. Meaning it comes somewhere here between root 9 and root 16. Meaning somewhere here some values between 3 to 4 here. So we can consider that 3.9 Bohr magnet, meaning 3.9 Bohr magneton magnetic moment will have 3 unpaired electrons. Fine. So once we have found out that there should be 3 unpaired electrons carried by this particular metal, then we can get the magnetic moment of 3.9. Now let's take the option one by one. First option, V2 plus and CO2 plus. Valence electrons of vanadium is 5 minus 2, meaning 3 unpaired electrons. Cobalt 9 minus 2, meaning D7 configuration, meaning there are 3 unpaired electrons. So this should be the option where both are having 3 unpaired electrons, and therefore the magnetic moment will be 3.9. Let us check with the other options. V2 plus Fe2 plus. Just now we have found out 3. It has 3 unpaired electrons. Iron valence electrons are 8 minus 2 D6 configuration, meaning 4 unpaired electrons, not the answer. Next one, CO2 plus and Fe2 plus. Cobalt, here we have found out 3, so it is 3. Iron we have found out 4, it is 4, so it is not the answer. Last option, Cr2 plus and Mn2 plus. Chromium 6 valence electrons minus 2 D4 configuration, 4 unpaired electrons, so this also cannot be option. Manganese 7 minus 2 5 unpaired electron, so A option is the right answer for the given question. The question is this way. Consider the hydrated ions of Ti2 plus, Vi2 plus, Ti3 plus and Se3 plus. The correct order of their spin-only magnetic moment. Here we have to consider hydrated ions. Ions when they are hydrated this way, meaning it is Ti H2O 6 times and 2 plus. Water is a weak field ligand. It is a weak field ligand which will not pair up the unpaired electrons. So, the atom in its ground state and in its ion state, it will have same number of in its ion state. In both states, they will have same number of unpaired electrons, because water here is not pairing the unpaired electron. So ground state, whatever the electrons unpaired are there, the same even the ion state also. So we have to figure out first the ions with their unpaired electrons. The options given here is Ti2 plus, Ti3 plus, V2 plus and Se3 plus. Valence electrons of titanium is 4 minus charge 2. It has 2 unpaired electrons. Titanium 4 valence electron minus 3 charge. It has 1 unpaired electron. These are unpaired electrons. And vanadium 5 minus 2. It has 3 unpaired electron. Scandium valence electron 3. Last all the 3 will have 0 unpaired electrons. Here the magnetic moment, when we arrange them in increasing order, vanadium falls first and then comes Ti2 plus, then comes 3 plus and scandium here. So the option will be this way, V2 plus greater than Ti2 plus, then Ti3 plus and then falls last Se3 plus. So when you look at the option, D option, here the options are not correct here. Yeah, here V2 plus, Ti2 plus, Ti3 plus and scandium. So D option is the correct answer given here. The question is the correct order of the calculated spin-only magnetic moment of the complexes A to D is given here. we are supposed to find out the correct order of the magnetic moment. We know that magnetic moment depends upon the unpaired electrons. Depends on unpaired electrons of the central atom in the complex or in the compound. Now we have to figure out which central atom in the complexes are having unpaired electrons. When we talk about complexes, crystal field theory will influence a lot for pairing of electrons or unpairing electrons. Usually, strong field ligands will pair up unpaired electrons. They will pair up unpaired electrons. Generally, metal will have no unpaired electrons after pairing up. We have to work out all the ligands. You cannot generalize like that, but on the surface we can say that strong field ligands will pair up unpaired electrons and the central metal atom in the complex will be left with no unpaired electrons. The other way, the weak field ligands will not pair up the unpaired electrons and therefore they will have some number of unpaired electrons. When you look at these options given here, H2O is a weak field ligand. In the options given above, H2O is the weak field ligand. So this complex should have some number of unpaired electrons. When we look at this carbonyl, cyanide and triphenyl phosphine, they are all strong field. Therefore, there should not be unpaired electron and these complexes all will be having no unpaired electrons. So, we will work out for on the surface when we observe that B option should be the right option, where B option will have more unpaired electrons. So, spin magnetic moment is more, but the rest all have strong field and moreover they all belong to same group. What are the metals given? Nickel, here also nickel, here palladium. All this belong to 10th group. 10th group are nickel, palladium and platinum, who has configuration D8S2. When these ligands, D8 in the sense the d orbital has 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. So as these ligands or strong field ligands, they will pair up this electron and left over with no unpaired electrons in the rest of the option. So B option should be the right answer. Let us check out. Now let us take one by one options. NiCO4, where carbonyl is let us find out the oxidation state first. As this is a neutral ligand, the metal will possess zero oxidation state. Second one, NiH2O taken 6 times and Cl2. As this is -2, the complex will be +2. As this is a neutral ligand, whatever the charge here will be the charge of the metal. So nickel here lies in +2 oxidation state. Let us take the third option, Na2, NiCN4. Here sodium is +2, so the complex will be -2. And here cyanide is -4, taken out becomes +4. So here nickel lies in +2 oxidation state here also. When we take the other one, palladium, PdCl2, PPH3 taken twice. Here this is -2, taken out becomes +2. This is a neutral ligand. So here palladium is in +2 oxidation state. In +2 oxidation state as nickel and palladium, they are in +2 oxidation state in this first option, and all these options, if they are in +2 oxidation state, they will have a configuration this way. As here, it is a strong ligand, the first option, A option, the strong ligand. So, it will pair up unpaired electrons and they will have +2 oxidation, meaning 3d8 configuration. As CO is a strong ligand, all the 2 electrons will get paired up. 0 unpaired electron, it will have 0 unpaired electron. In this will possess 0 unpaired electron. Second option, here nickel is in +2 oxidation state in 3d8. As this is a weak field ligand, it will not pair up unpaired electron. So these two will be left over. So this will have 2 unpaired electrons here. When we look at the third option, as it is a strong field ligand, this is also a strong field. As it is a strong field ligand, it will pair up unpaired electron. This will also be left over with no unpaired electron. This also has 3d8 in +2 and there are no unpaired electrons here. No unpaired electrons here. 2 unpaired electrons here. I will put 0 here, no unpaired electrons. The last one, this is also a strong field ligand and it will pair up those 2 electrons in 3d8. This will also have no unpaired electrons. Therefore, B option should be the highest option and all these are having 0. So, they will all have the same magnetic moment. So, our option B is the right answer. Here the question is, third ionization enthalpy is minimum for. The options are like that. To find out third ionization enthalpy, first we should be clear with the electronic configuration. The ground state electronic configuration of nickel is D8S2, 3D8 4S2. Cobalt is D7S2, manganese D5S2, iron D6S2. We are asked about third ionization enthalpy, meaning to remove the third electron. Third electron meaning we should first know the second ionization enthalpy's electronic configuration, meaning after losing 2 electrons, what is the electronic configuration of the element? After losing 2 electrons, by losing 2 electrons, the configuration becomes D8 here by losing 2, by losing 2 D7, by losing 2 D5, by losing 2 D6 configuration. Third ionization enthalpy is removing the third electron, meaning from this we have to remove 1 electron. Already 2 are lost, you are going to remove the last third electron. Minus third electron. When you want to remove the third electron here, iron has D6 configuration. They are talking about minimum. So iron has D6 configuration, meaning there are 6 electrons in its d orbital this way, 5 and 6. If at all it loses this 1 electron, it will get stable d5 configuration by losing 1 electron. Therefore, it is very easy to lose this 1 electron in iron. So, this is the element which will have minimum third ionization enthalpy, whereas manganese will have maximum third ionization enthalpy. This has minimum third ionization enthalpy. So, D will be the answer for the question. The question is like that. The correct order of 3D metal oxides according to their oxidation number. Correct order according to their oxidation number. The compounds are this way: CrO3, Fe2O3, MnO2, V2O5, this is MnO2, this is V2O5, Cu2O, which are A, B, C, D, E respectively. Here CrO3, the compounds are CrO3, Fe2O3, MnO2, V2O5, Cu2O. Oxidation state here of chromium is, this is -6 and chromium is in +6. This is -6, so iron +6 by 2 +3. Oxygen -4 here, so it is +4. It is -10 here, so this is +10 by 2 +5. It is -2 here, so +2 by 2 atoms here, so +1. When you look at the oxidation state, these are like this. And when we look at the option, it is A, B, C, D, E. So, E has the lowest value, E. It is E, B, C, D, A. So, it is E comes very low, and then comes B, and then comes C, then comes D, and then it is A, which is highest oxidation state. So our option should be A option, which is AdCbe. AdCbe is the option. Here the question is the incorrect relationship in the following page in relation to ionization enthalpy. The incorrect relationship. We all know that as the charge on the ion increases, the positive charge on the ion increases, the size decreases and it is difficult to remove the electron. As the charge on cation increases, Z effect increases, difficult to remove the electron. Difficult to remove electron. Meaning successive ionization enthalpy is always high. Successive IE is always high. Always high for the same ions. For same atoms or ions. For same ions. Therefore, here first option is Mn plus and Mn2 plus, both same ions. So 2 plus will be always high. So this option is correct option. When you look at the D option, both are same atoms. 2 plus, 3 plus, 3 plus more charge. So always it will have more ionization enthalpy. This option is also right. When we look at the B and C, there are different atoms. We have to work out this. And now B option, that is Mn plus and Cr plus, we have to talk in with respect to configuration. Manganese valence electrons are 7 minus 1, meaning it has D6 configuration. Chromium 6 minus 1, D5 configuration. D5 is half-filled stable configuration. Half-filled and stable configuration. So it should be this way and is given in the same way. So B option is also right answer. So our answer might be C option. Let us check out with C option. That is Mn2 plus and Fe2 plus different ions. Manganese valence electron 7, lost 2 electrons, have D5 configuration. Iron 8 valence electron, lost 2, D6 configuration. And here completely half filled D5, it should be more stable. So the option should be the other way, but here they have given minus. So this is the incorrect option here. Our answer is C option here. The question is this way: the oxidation state of chromium in the final product formed by the reaction between Ki and acidified dichromate. So they are talking about the oxidation state of final product. Now let us work out here. Here the reaction is this way: acidified potassium dichromate H2SO4 reacted with potassium iodide gives what? Here dichromate is a strong oxidizing agent and oxidizes I minus to I2. It oxidizes I minus to I2, whereas itself get reduced to chromic sulfate Cr2SO4 thrice, where chromium is in +3 oxidation state, and potassium here will get reduced to K2SO4. So potassium dichromate meaning chromium ion will undergo reduction. From here to here it undergoes reduction, whereas iodide ion get oxidized to I2, meaning Cr2O7 2 minus will get reduced to Cr3 plus, whereas here it is chromium is +6, here +3. Therefore our answer should be D option. The question is like that: what happens when potassium iodide reacts with potassium dichromate in acidic medium? So let's write the reaction. Potassium dichromate K2Cr2O7 in acidic medium, that is with H2SO4, and reacting with potassium iodide gives what? Let's take the reaction this way. Potassium dichromate is an oxidizing agent, oxidizes I minus to I2, and itself will get reduced to chromic sulfate. This is oxidized, and this is reduced to Cr2SO4 thrice, where potassium will get reduced to K2SO4. It changes to K2SO4, meaning here the final products are potassium sulfate and liberated iodine, and chromic sulfate is formed. When you look at the option, all are correct here. So our answer should be D option.